Welcome back, generals, to another Let's Fix General 0 Hour to make the best game ever. Good, so let's see what we can do. What we can do. So let's take a look at this guy we left off here. Snapshot was moved. Methods were named, yeah. Okay, there's no answers here, okay. Fix left out phrasing. Let me see what's near here. Enabled support for all aspect ratios and modern resolutions. That was closed. Okay. Why? This change removes the 4x3. Yeah, I begin to support. Main menu, shell map and loading screen videos won't load if the game runs on Linux. Shell map and loading screen. Loading screens width after launching the game won't start. This is a practical issue for us. I don't know what this Proton thing is. I think it's not relevant because we plan to build a native Linux compatibility, so it probably doesn't matter. Like, why does it have to be compatible with like a compatibility layer emulator or whatever that is? That do we count on emulators to be compatible for this game? Tested this recently. I could not reproduce the memory leak, he says. Okay. Okay, let me also try this thing. RTS. Let me disable everything except 0. Okay, let me open my task manager. Details. And F5. No, builds. Okay. What else do we have? This has been caused by the following: the recorder and playback. Yeah. New key mapping. Again. Good, so this one has compiled. Let me go to configuration manager, install. Okay, 0 hour, generals. There we go. I finally disabled the Discord overlay, which was super annoying. Why do we have assertion failure? That I don't understand. We have turned off debugging. Crashing. Oh no, it's turned on. Oh, Jesus Christ. Let me reconfigure this bullshit. Yes, files can be moved in game engine slowly. Check issue 555 for overviews. And keeping track. Okay. Good. So install. Good. So so we need to check memory leak with hackers. No. Let me see. I think we have a map somewhere. Lotus vehicle hack. I think it's this one. There we go. Yeah. Okay, so here we have our task manager. Then we go to generals. There. There's generals. Memory looks pretty stable right now. That's good. Can also do this here. So general 0hour.exe takes just 8% CPU and some GPU. Good. Memory looks very good. Good. Then we put it here on the side. Yeah. Good. Let's see. So we take these guys and we start hacking. Yeah. I see memory is rising. No, it stopped. No, it still rises. Let's put some more guys here. It looks like the memory is rising, no? Let's see. Also, the frame rate gets awfully, awfully slow. Oh my gosh. The lag is unreal. I certainly see the memory is rising. Yeah, it looks like there's a memory leak. Now the question is, what is it that is leaking? Wow, it's still leaking when we pause. Oh, that's interesting. That's interesting. I didn't expect that. Let's see if we go out of the screen, then it stops. Yeah. Okay, so it's only if it's in view. So it must be something with it's something with a rendering. It's not a logic issue, it's a rendering issue. Okay, so what I can already say here, I can reproduce this issue with this code in VS 2022 release 0 hour. So the can we I probably need to create a pix capture, right? By the way, does it? We haven't put PDB, right? I hope so. I think we need to make a pix capture, yeah. Attach. Ah, shit, we already have a debugger attached. Okay, let me start a new session. Generals, English. Skirmish. Okay, so we go to refresh. Oh, we cannot attach to x86. Oh, that is a problem. Pix x86. Jesus. Pix for Windows x86. Here, Win32 apps. But there's only x86, x64 version. Pix for Windows, Win32. Let's see what ChatGPT says. Can we use Pix for Windows with x86 executables? Run, yeah, executables. Can we use Pix for Windows? No, does not support. Yeah. Okay. Oh, that's sad. I thought it would work with x86. Huh. Okay, well, in that case, so how do we find the memory leak? As far as I'm aware, there's some sort of leak detector already built in the game. Because the memory pool keeps track of leaks, right? Let me see. Memory. Maybe you can look around a bit though. The debug shower. Debug shower. Let me go back to the issue. So, disabled effect by a shower is a zero effect which spawns a slave system. That is part of the overall building. Removing the slave system will solve the leak, but it doesn't look as good. Slave system. Slave system. Removing the slave system. Removing the slave system will solve the leak. Okay, so a slave system is leaking. Let's see what that is. Slave system. Here. F slave system. Let me search for that string. Oof. Ah, here. There we go. Slave system, parse ASCII string. There we go. So that refers to M slave system name. Okay, let's see where this is used. The slave system is used. Create slave system. Okay, there we go. And that creates it here and it returns it. Okay. And then here, M slave system. Slave template. Find template. What does it return? Find. Okay, it just returns a pointer. That's fine. Okay, so this slave guy, where's it being used then? Create slave. Create slave is here. If slave, then set slave. Okay. Set slave. And so the slave is stored here as a raw pointer. Okay, so now the question is that cleaned up on all code paths? The slave. Slave. I do wonder if we go to general's game patch, and we search for the slave system, how many hits do we get? Is this like regularly used or? Oh, it is. Well, a couple times. Yeah. It's used for a bunch of things. Yeah. Mm-hmm. 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 Okay, so the slave system. The slave system. Well, it's not destroyed here, isn't it? We have a function here, it's called destroy. Stop emitting. Maybe this destroy is somewhere else called. Set master. Slave system set master. I wonder why this is called a set slave. Huh. So who is deleting that slave thingy? Tell any of our slave system that we are going away. And then who? Our slave doesn't have us as a master. Slave system. Okay, so the slave is also a particle system. And then what? Okay, so it looks like we are not supposed. Stop emitting. If we don't, it will leak forever. Okay. So this slave system. That's curious. Particle system. Do we have it? Yeah, the destructor is here. So I wonder. How is this being destroyed then? So here it claims that we are responsible for it. But are we still responsible after we have detached ourselves as a master of that slave? If master system, tell any master that we are going away. That is also a thing. If we are a master system, if we have a master, yeah. Destroy particle system and all of its particles. How is this particle deleted? I don't understand. Let's put a breakpoint in here. How about that? Let's take one guy. Let's start hacking. Oh, we are not attached. Let me attach to the process. So we attach. We don't hit the breakpoint. Probably because this is not a debug build. Yeah. Let's unoptimize this particle system thingy. Yeah, take this guy, put that here, stop. Let me exit mission. We could also make, actually, we can make a captcha with, if we don't figure out like what actually leaks manually, then we can make a captcha with ETW. Yeah, that should catch the memory leak. But maybe we can figure it out just by studying the code a bit. We know it has something to do with the slave system. It's also nice to study the code because it helps us understand how the stuff works. Okay, so can we hit the breakpoint now? Particle system. Okay, put the breakpoint in here. There we go. So it has no slave system. Let me see. What is the call stack? What is this object? This object is disabled effect binary shower 1. It's a 0 effect which spawns a slave system of that. Okay, so we get a destruction on shower 1 and on shower 0 as well. On both. And sonic range. So it works. Get the destruction there. Binary shower. Here, slave system. So we have a binary shower 0 and the slave is a shower 1, and yeah, they are being destroyed. Okay, so it's not that. The destruction works. Well, in that case, but hold on. Let me see the core stack. Delete instance. Free block. So this guy contains no slave. This contains a slave and a master. Yeah, so the binary shower 0 has a slave here. And the slave is 6474. 6474. We set it to 0. And then we have the shower 1, and that is, that's a different address. Particle system list. There are a lot of particles in here. Track debris dirt right. It looks like there's some leaking thingies in here. Track debris dirt right. Okay, but it's not the binary shower. Ah, here, we have some showers in here. Let me get this guy. Let me get this list here in the view. Let me see the guys down here. What is in this list? We have a shower 0 and a shower 1. Another shower 0, 1. So we have multiple shower 1s and 0s. Let me so there were 90 elements or so in the list. Let's hack for a little bit here. Oops. Let's hack for a bit and see if the list grows or if it stays the same. Oops. Core stack. It grows. It does grow. Okay, but it's because we have more people hacking now. Hold on. So it's 1F, 14F. Okay, let's hack a bit more and see if it gets significantly past 1F4, 14F, or if it stays there. 146, that's smaller. Okay, so it's not particle systems that are leaking, it's something else. Okay. Okay. I will be right back. Okay, we are back. So it's not the particle systems itself that are leaking, but perhaps it is something that is part of the particle system, right? So if we go back to the particle system, to the destructor, yeah. What kind of resources do we have? Do we allocate anything in here? Let me see. New. New template. Okay, so we allocate something here. New template. Find template. This template map. Okay. Template map. Okay, but that's part of a manager. Yeah, I think this is just like persistent. It needs to be there always. That's fine. Okay, here we have a particle instance. Create particle. Yeah, maybe it has something to do with this guy. Yeah, so the particle system owns particles. Yeah. So we probably need to look at this guy. And that's it. New particle. Is there anything else? New instance. So there's a particle system is being allocated here. This template thingy and this one particle. I think this particle needs a little bit of inspection. Create particle. Create particle. Let's see. So we create one here. If it's null, okay. If attached system name is empty, if it's not empty, actually create a particle. Okay. Create slaved particle. Okay, this looks interesting. Let's put a breakpoint in here. Let's put a breakpoint. So we create a particle here. No. And then, now we have created a particle. And now what? Huh. Well, there's a leak. Okay. So we have a P, but nothing is done with it. Oh, the question is this is this registering anywhere? Let's see. Maybe it's registering. No. Well, let's look in the constructor of this guy as well. Maybe it's registering in here. Here, particle, because it does have a particle system. M system. So there is so the particle knows about the system, but not the other way around, right? Let me see. System. Here. Add this particle to the global list. Okay, so it is being kept track of. And also here, M system add particle. Okay, so it's not lost. You don't have to do anything with the pointer. Okay. Okay, so it is being taken care of here. And when we destroy it, then we call remove particle. Yeah. And here as well. System under control. Okay, it doesn't seem to be suspicious so far. I mean, it's quite a bit more complicated setup, right? But it seems to be fine. So here we have a slave system. That's another interesting place. Merge related particle system, M slave system. Merge. What does that do? Generate particle info. What does that do? Compute, blah, blah. Blah, blah. Okay, blah, blah. This is stack local. Particle info, static it is. Static. Wind randomness. Merge info. It creates a copy here. Oh, that's stupid. Generate one from the slave system. Wait, so all right, so it has to create a copy here because oh god. Oh boy. I see. Slave. I see. Okay, it's not wrong, but it's not nice. It should just return a copy. That would be the simplest instead of the static bullshit. Yeah. I think back in the day, return value optimization maybe was not a thing yet. That could be. Okay, so far there's no allocations here. It's just crunching some datas. Mesh info. Okay, so that's fine, but here it creates a new particle with this merge info. Priority critical. Remove oldest particle. Num in excess. Okay, that's interesting value. Let me put that to minus 4,203. That seems like an odd number. Get particle count. That's probably right. Num in excess. Yeah, okay, no, it's correct. So we have 4,200 like free particle slots left, right? That's fine, yeah. And so we create a new particle here. Yeah. What is happening with this particle? Let's put a breakpoint here. So this one is being added to to here. Particle head. What is this? Particle tail. Retaining local creation order. Particle system. System next. Next. No, okay, so particle system has a few. Let me put that into the watch. So system particles head 1, 2, 3, 4, 5, and that is 0. Good. So that has 1, 2, 3, 4 particles right now. And here we add another one to the end. There we go. Yeah, so now we have one more. Now we have 1, 2, 3, 4, 5. Yeah. This one is 0. Okay, so this works. Previous is tail. 5. Add particle. Add this particle to the particle system list. Okay, so it creates some extra particle here. Yeah, but that doesn't seem to be too suspicious to begin with, because it's just another particle. So it creates a particle here and a slave particle, and that's it. Yeah. 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 what would be interesting to test if we comment this here out, this guy, and we run the same test, will the leak still happen? Like all things equal, just this commented out, will the leak still happen? Let's see. Okay, let me remove that breakpoint. Okay. Okay. It's still leaking. It doesn't show the 1 anymore. Was it leaking? No. No, it doesn't seem to be leaking anymore. No. It is a bit alternating, but it seems stable. Yeah. Okay. So okay, so commenting this out helps. Okay. Now that is already a hint. So this slave system, this particle, we delete the slave system, but then what would be wrong with this particle? Is there something wrong with this merge info thingy? Merge info, particle. Maybe there's something special about the setup of this particle. Let me see the setup of the binary shower here. The lifetime is set to 100. 100. System lifetime is 70. 70. Yeah. 70. Okay, and the other one here, lifetime is 60, and system lifetime is also 70. Particle. Systems particle. Okay, so particles are added locally to the particle system. The particle system owns the particles. They're not added globally anywhere, right? Or are they? They are. In the particle system manager, they also added. That's interesting. Particle system manager. Add particle. And what does it do then? If it's in here? in the overall list. What does this do? All particles head. Let's see. What is it used for? Remove oldest particles. Ah. Aha. I see. Delete instance. So it's in a global list so that we can like delete particles from any particle system depending on priorities. Okay, that makes sense. Okay, maybe it would be, let me start a new session with the code compiled back in, the offending code. We have put it back in, right? Yeah. I would like to see what happens here, if we get like a huge accumulation of particles or not. Lotus vehicle hack. There we go. Good. So we start hacking here. Performance is degrading. There's a binary shower and performance also tanks. Let's put a breakpoint in here. So what does that mean? Create particle. Num in excess 1. Aha. So the particle count has been exceeded, probably because of the memory leak. Maybe. And so what does it do then? Particles head. Oh, it goes through all priorities. Oh, Jesus. Huh? What? It is a priority critical. Aha. So it only clears up non-critical ones. Okay. Interesting. Interesting. Priority always render. But it's marked here critical. Always render. Priority. Right, I understand. It's only allowed to delete particles of a priority that is lower than the one that we want to create a new particle for. Okay, well then this means that it cannot remove the oldest particle, could not remove, and so it should return here, right? Yeah, return. So it cannot create a new particle then. I see. So we have a huge number of particles somewhere. Good. So this leak, where does this happen? Where does this happen? This slave particle. Slave particle. Slave system. Okay, how about we go into our particle system to the destructor, and we put a breakpoint in here. Yeah, particle system. So when this guy is deleted, then it has a particle M system particles head. So it has here 1, 2, 3, 4. 4 guys inside. And we delete it. Is that healthy? Here. Oh, hold on. So particle system. Okay, the particle system list actually gets pretty huge now. But that's probably because we hack with so many guys. Yeah. Let me stop the hacking with all these guys. Just one guy, please. It's a more controlled environment. There we go. Okay, so here we have the slave system now. This is the slave guy. And this guy, it doesn't have a particles head. Huh, is that expected? Let me see. So here we have a master, because he has a slave. He also doesn't have particles here. Particles head. Systems particle head. So the difference is, see here, if you only have one guy hacking, then this list is empty. But when we had like multiple guys hacking, then there were still particles in here, probably because it was this particle system list was bigger. So if we just have one guy, hacking, will we also have a memory leak then? Let's take our 4 guys. 4 guys. Oops. So 4 guys doing the Lord's work. I don't see any increase. So maybe the memory leak only happens when we reach a certain particle cap, right? Like when it starts truncating the particle list, and then there's something going wrong. Could that be? Let's take another row here. Let's try to find the thresholds. Don't see a leak right now. Let's take another row here. Let's take the whole row here. Let's take all these guys. Good. See no leaks right now. Now I do. No? I'm seeing nothing here. Seems pretty calm. Why is that? Let's take another bulk here. Another bunch. It's not happening now. Did we properly compile it? Let me restart. Particle system. Up to date, it says. Huh? Why is it not leaking now? That's interesting. Maybe it doesn't happen 100%, but that's also weird. So we take this bulk and we start hacking. Memory is 234 now. Okay, certainly leaking now, right? Let's stop. Let's stop one row. Now it has stopped. Let's continue with these guys again. Now it's not leaking. Huh? That's strange. Let's do more guys. Okay, that's odd. So it started leaking, then we stopped hacking with some guys, and then it doesn't leak anymore. That's strange. Huh. What is that bullshit? Okay, let's restart the mission. Let's do it again. Start hacking. Looks fine. Okay, let's restart the session. Okay, that is extra weird. I would have expected that it just is consistently broken and not has this weird behavior. When we stop hacking, it doesn't leak anymore. Huh. So let's do a fresh run. Super fresh. Yeah. You take all the hackers and we start hacking. And we observe our memory. Our memory is certainly growing now. Massively. So it is leaking right now. But why does it not leak anymore when we stop? That's weird. It's really it's massively leaking now. That's wild. So if we destroy this here, we have no particles head. Yeah, slave system. Okay. Let's put a breakpoint in here. Is this ever hit? No. Okay. So where's this guy cleared? Let me see. Remove particle. Remove particle. Let's put a breakpoint in here. Remove particle. Particle to remove. Call stack. Aha, on destruction of the particle. Remove given particle from the list. Yeah. Is that a private function? It's public for some reason. What? Where's this called? It shouldn't be public. It should be private. It should be made a friend, maybe. Okay, remove particle. Remove links. Oof. Particle to remove. System next. Pref. Pref. Next. Pref. So the next system gets a pref. Yeah. Seems to be right. Particle remove equals head. Particle to remove equals hat. Mm-hmm. Mm-hmm. It seems to be correct here, this how the list is being treated, yeah. Yeah, it seems to be good. Till the particle system that this particle is gone. Let me put a breakpoint in here. Is that ever hit? Nope. Why is this leaking? That's a very strange issue. Very strange. Particle. Old particle, delete instance. So the particle systems, they're not capping. Well, 3,410, that's quite a lot. It's the particles that have the cap. The systems, they don't have a cap. Seems like it. Particle system list. Poof. What is this here? What? This would cause an infinite loop, no? if Because it doesn't increment here. What the hell is that bullshit? That makes no sense. It's also it's never hit, right? Yeah. And that's weird. This is absolutely weird. Jesus Christ. No, this makes no sense. The way this should be is this plus plus IT should be here. This should be removed. This condition here. And then this can be removed. And this can be removed. Yeah. Jesus Christ. Let me create a report for that. Blank issue. Particular system updates is bogus. This would cause infinite loop. This would cause infinite loop if it were to hit. Let's type bug miner. Okay, well, it's not a problematic question right now. As long as it doesn't hit, it's not a actual bug. Or yeah, not a tangible bug. But yeah, it shouldn't be there. That's stupid. So why is this leaking? System particles head. Do we have a counter here? Particle count. I mean, to me, it looks pretty. Looks all good. We have here in the destructor, there is the loop for deleting the instance while head. It seems to be right. It's not even hit. Let me, we need to take a closer look at the slave, I think. Because here it says, if we don't, it will leak forever. That is interesting. That I find really interesting. Let me put a breakpoint in here. Well, that's never called. Stop emitting. That's interesting. This comment is interesting because it would imply. Is this ever called anywhere? Let me see. What was it? Breakpoints. This one, destroy. Let me see if this is called anywhere ever. Is destroyed. What is that for? Destroy. Particle system, destroy. Destroy ourselves. What is that? What does that mean? It's not really doing anything. It just sets a flag, is destroyed true, and then what? Then it skips some code in here. Oh. Well, I mean, it doesn't seem to be that is responsible for anything because it's never calling this guy. But curious. Instead, it is updating here and it's destroying here. All right. We have a particle. P equals P next system. Yeah. And then deletes the old particle. Yeah. So here we have a set master, set slave. So now have a set master. I don't see anything leaking. Everything seems to be fine. I wonder. Okay, how about we add some debugs here? I would like to know std unordered map. Let's put uint ptrt and no, unordered set particle system s systems. Okay, it's to include maybe just do set, just set. Okay, systems dot emplace this. Okay, and then on the destructor we do systems. How do we delete? Is there a direct function for this? Erase. That takes an iterator, right? Erase dot find this. Okay, so I would like to see if there are any like excessive amount of systems in this list. And then we do the same for the particle. Yeah. Because the problem is with the linked list, it's hard to see like, okay, how many guys are actually there, right? Oh, we do get a hit here. Look at that. Oh, what does that do? Core stack, stop client particle system. Okay. Okay, but that doesn't seem to be relevant for our case. That also hits now. Okay. Good. So let's take these guys. Good. So is it leaking? Yes, looks like it. Okay. Then let's go to here. Let's put a breakpoint in here. Systems 923. 923. Okay. Let's wait a moment. Put a breakpoint again. 944. It's a bit more. $899. Okay, no, it doesn't seem to. The particle systems don't grow. 951. Yeah, it seems to be fine. Okay, let's add the same for the particles. Let's go to particle here. particles, s particles, particles dot emplace this, and then here erase find this. Okay, so if that also doesn't grow, then it's not that, it's something else happening. Yeah. I mean, it has to be some resource that belongs to the particle somehow, right? I don't understand. So we hack. Memory is rising. Then let's put a breakpoint here. S particles 2500. Okay. Which seems like a plausible number. Yeah. Yeah. So it's not leaking. I wonder. I wonder. The memory pool, game memory. I wonder, like, if when we allocate, the pool grows, right? The pool has to grow. Let me see. Where does this happen? Yeah. Memory pool. Allocate block implementation. Has any free blocks? Create blob. Let's put a breakpoint in here. It does hit. Yeah. Create particle. Okay, so create particle. This pool is not allowed to grow. Let's put a breakpoint in here. No, that's not hitting. Okay. So it's not a matter of it's not a matter of growing the pool, right? Allocate block. Let me see. Blob. Allocate single block. use blocks in pool. So it doesn't seem to be a problem with the memory allocator here. My thought was maybe, okay, maybe there's a bad case of fragmentation, but that shouldn't happen, right? We always reuse slots from this blob, right? Yeah. And it never goes in here. Yeah. So it's not that. But we allocate here, yeah. Create particle. You also allocate here. Create particle also here. Yeah. Yeah. So these are the two places where we create particles. Where does this happen? That's a curious issue, yeah. I put a breakpoint here. Allocate single block. Oh, cannot step inside there. It's optimized. Can we see blob? Blob. Blob. First free block. Yeah. So there are 3 guys in there. Yeah. What happens if there's no free one in there? Yeah, this looks like it should be all good. Yeah. I don't see a problem. The code looks all right. It's really inefficient, that we can see, but it works. It shouldn't leak, but it does. Oh boy. Yeah, what is the problem? I don't know. I don't know. I don't know what the problem is here. Mm, hmm. 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 Okay. The only lead we have right now is that if this one is not compiled in, there's no leak. That's weird. Like if this would leak, then this would leak as well, right? But it doesn't. Let me see what's inside this particle. Let me put a breakpoint here. So, so we go in here. Okay, what's in there? There's nothing going on here. I don't see any allocations. Let me actually see the members of this particle guy. The particle guy has a linked list here. It has the owner system, and then it has some settings here. Yeah. And then it has this system under control. The particle system attached to this particle. Okay. Okay. That's a bit weird here. That it's a union. I don't see anything suspicious looking here. This one seems to be not used, right? What is this idea? That's weird. What? How this works, I don't know. That is weird that the ID can be the pointer and vice versa. What? It's never assigned. To me, this looks so wrong here. I think this was meant to be a system here. Huh? I don't understand. Maybe it's correct. I find this really weird. Very strange. Very strange. And to me, this looks totally wrong. I don't understand. This is weird. It's really weird. Because the pointer is not an ID. Or is it? No, it's not. I don't understand. This seems wrong. This looks weird. Let me make a post for this. What the fuck? What? Should clarify that this is a union. Class particle union. Labels, investigate, minor. Actually, let me put this comment here. Good. Yeah, we still don't know what the problem is. I don't see any reason why particle would leak. I don't. System under control, destroy. Remove particle. Detach control particle. Remove from the global list. I don't know. I don't know. There's something going on, and it's really not obvious what that will be. Yeah, I don't know. Particles erase. It's not that. Create particle. Slave system. Is there anything else special with a slave system? We don't do... I don't think we enter here. This is for safe loading, right? Update. Destroy. We don't call destroy. Slave system ID. I wonder why it stores the slave system ID. If it already has a pointer to the slave, why? Is it maybe for performance reason? It could fetch it from the slave. Yeah, I mean it needs to load this then. But if I would have implemented, I would have just like taken it from here instead of storing it, unless it's like really performance critical to query this without accessing the slave actually, but it doesn't seem to be like that. It's used in Xfer. Set slave. Man, what could be the problem here? Create slave particle. Could there maybe be an issue like if you create one particle and then directly afterwards you create another, then something is wrong? Could that be a thing? It's not going in here either, right? could be the problem? I don't know. I don't know. It's probably something stupid. Yeah. Something really, really stupid. Huh. What could it be? What could it be? What could it be? Okay, this part, I think we need to look at we maybe need to look at what is being done with this particle. Delete instance. Okay, so apparently there is some sort of debug for leaks. Let's see if that would catch anything. Game memory. Here, debug pool report leads, memory pool debug. How do we enable that? Memory pool debug is enabled, but it's disabled here because it requires RTS debug. Oof. Okay. Can we just compile in memory pool debug here? Debug pool report leaks. Where is it reporting it? Debug log. Okay, so we need the debug log. RTS debug. Do we really need... Why do we need RTS debug? Would be debug logging enough? Let me see. Debug log debug assert crash. Okay, let's say enable debug. Option debug. We stop debugging. Memory pool debug. Configure. Okay, let's compile that guy. I still cannot reproduce a problem. Could be a Gentoo or modded data issue. No, it's not. It's not a Gentoo issue. Maybe he has the fault-tolerant heap enabled. Perhaps you have fault-tolerant heap enabled. But I think it still happens with the fault-tolerant heap. If there was a null element in that, then the loop would be infinite. Yeah. Okay, so we have memory pool debug enabled. Let's see what happens. Okay, solo play, skirmish. And let's remove this here. Good. Take these guys, start hacking. All right. Check if we are leaking. We are. By the way, did we generate a new solution? Let me go to memory, game memory. Yeah, let me put a breakpoint in here. Code is not a hit. Well, that's not a good sign. I wonder if it does anything. It might not do anything. I think we didn't build yet, or did we? We did. Oh, right. There we go. Skirmish. Okay, let's see if that still gives us the issue. Assertion failure. Sorting renderer. What is that? Debug break. Max overlapping nodes. Okay. Ignore. Okay, so is it leaking? Yeah. Yeah. Good. Then we exit mission. Main menu, exit game. Okay, now it hits this guy and leak. Good. So something is leaking. Good. Yeah, okay, let's just have it log out and let's check the game log here. There were 129,000 memory leaks. Okay. Okay. Now let's check the log. Leaked a block. Sorting renderer. Oh. So it's from the sorting renderer. Okay. Interesting. Sorting renderer CPP. Sorting renderer. Release refs. Okay, so we did hit this guy. Max overlapping nodes. Insert to sorting pool. Let me put a breakpoint in here. I have to say this this leak detector is pretty cool that it's built in there. It's really helpful. Okay, let's see. Skirmish. Okay. Okay. Oh. What? Okay, so for some reason we can't put a breakpoint in here. Why not? Let's see where it's called. Flush. State. 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 So what is the state? Sorted list head. Release refs. Release refs. Insert to sorting pool. Sorting renderer class. Flush. So what does it do? What is the state thingy? Release refs. What does that do? State. State. Ref PTR release. Okay. Okay. Vertex streams 2. Okay, so let me look at... Oh shit, now we lost our debug. Shit, we should have created a copy of it. We still have it here. There we go. Sorting renderer. So leak the block of size 676. 676. What is 676 large here? Something that is leaking. Let me get this call stack here for safekeeping. Notepad. And then what is it? Sorting state. So sorting node so the sorting node struct itself. The sorting node struct itself. Leak the block of size. Sorting node struct. Get sorting structs. Let me see. Aha, so it allocates it here. And then what? State. Yeah. State. State. Aha. State removed. Does that mean it removes it from the list? Yeah, it removes it from this list there. Aha. And so here it cannot insert it into the sorting pool. And it asserts. So this limit here is too small. Okay, that limit aside, nodes, overlapping node count, yeah. So I think the problem here is it's being removed. And then it's not deleted here. Yeah. So where's it typically deleted then? Let me see, is this called anywhere else, this function? No, it's just there. Yeah, state, insert to sorting pool. State, release res. Okay, so either we could delete it in here. Delete head, dinit. Delete head, yeah. Sorted lists that contains sorting node struct, yeah. Okay, so this one is leaking, so we can either delete it here. Yeah, we have to delete it here. Yeah, delete state. So this would be at bug fix. Today's 11/05/2025. Deletes fixes memory leak when a lot of particles are on screen. A lot of fixed memory leak when pool is exhausted. This was reproducible by using hackers to disable. This was reproducible by using the this was reproducible with binary shower particles of the China hacker. Binary shower particles. Okay, let's try this. Okay, I'm pretty confident that this solves the problem then. Ignore. Okay, let's remove this. Okay, solo, skirmish. Okay, we take these guys and we observe the memory. Ignore. Yeah, it's still growing a bit, but not as extreme as before. But it is creeping up a little bit, isn't it? Oh, yeah, not really. A tiny bit it's creeping up. But it looks like the big leak is fixed. Yeah. Let's see what is left. Okay, there's still 5,000 memory leaks. Yeah. Simple object iterator clump pool. Okay, so there is something else going on. Let me create a copy of that as well. Simple object iterator clump pool. Block of size 16. So this guy. Oof. Okay. So there's an iterator. Okay, where's this being used? Oof. Okay, so the iterator needs to be allocated. That's why. Why is this not a stack object? Why is an iterator? It's 16 bytes. Jesus Christ! Why does not make it local? Why does it need to be allocated? What the hell is that? Why does a 16-byte iterator need to be allocated? What the hell is that bullshit? Just copy it. 16 bytes. Just copy the iterator. Yeah, that's outrageous. That's garbage. Just copy this thing. There's 16 bytes. There's nothing. Yeah, that's stupid. That's really stupid. Yeah, I think that's a waste. That is a waste. Okay, but that aside, well, where would it be leaked then? We have a constructor here. Okay, I guess we need to launch the game and see if we get where this thing is being called from. Ah, Jesus Christ. Okay, skirmish. Okay. All right. Good. Let's put a breakpoint here. It's not being called. Ignore. It is called. Okay, excellent. Stealth detector update. Stealth detector update. Okay. Hold. What does this memory pool objects holder do? Right. So it will delete it at the end of it. Okay. That's fair. So this one seems to be fine then. No, it's just that one being called. Let me see if this one is called. Can't put a... New instance. Hold. Release. Item holder, really. Why is this being hold here? That's weird. It seems to be obsolete here, this item holder. Or is it not? So iter next. Iterator next. Update sleep, update rain. So I don't know if it's this guy or if it's created somewhere else. It's really not clear. Because this only says what is being leaked. It doesn't say where it is leaked from, right? It doesn't say who has allocated this guy, right? But we only get calls here from this one. So it seems to be related to this. Maybe not. What we can also do is we can just look over all the others to see if there are any suspicious ones. Okay, so if there is a hold behind it, then it should be okay, right? Yeah. Yeah. Okay, let's see the allocations down here. Here. Okay, this one also has a holder. That's so stupid with the holder. It really is. That is retarded. This iterator should not be allocated. It should just be a stack object. I don't understand. They're so retarded. Okay, but I don't see an error so far. Unless the iter holder calls release somewhere later, but that seems unlikely. I don't see any issue here. Seems to be fine. Okay. So the simple object iterator. So I don't see it. No, there's a hold here. Well, does the memory pool object holder work correctly? Let me see. Yeah. 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 Exception safety. Useful for iterators. I don't see where this leak is from. So what we could do is we could make this simple object iterator simply not an allocation. That should get rid of the problem, right? But it's a bigger change because it will touch a bunch of files. But I don't understand why this is allocation. That is retarded. It really is. Is this object holder used for anything else? It is used quite a bit. Object iterator. Why is this using a holder here? What is this doing? Eta arc. To me, it looks like this eta holder is totally useless. because it doesn't do anything. Yeah. Totally useless. Yeah. Strange. There's so much garbage in here. It's unbelievable. How does this game work? I don't know. So I'm not seeing the problem right now, but that doesn't mean that there is no problem. It claims it leaks 5,000 times here, the simple object iterator. Good, so. It must be somewhere. It must be somewhere. It is definitely the stealth detector update that is being called over and over and over again. Is it any other one that is offending, or is it just this one? Ah, well, we don't see where it's coming from, right? Yeah. But we also have another iterator leaking here in partition manager. Huh. Hold on. Aha, so it is leaking in here. Is that true? Hold on. New instance. Huh. Let me see. What is allocating in here? Just this. Clump. Clump. Ah. So this clump is not being cleaned up. Aha. Okay. How do we... make empty. There's a delete here. Make empty. Clump. First clump. Current clump. Make empty. It is called here. Make empty. Can we put a breakpoint here? Yeah. Huh. It's not hitting. Make empty is not hitting. Why not? Simple object iterator. We cannot put a breakpoint in there. How about we de-optimize this file? Pragma optimize off. Good. So also let me launch the game in with quick start. I don't want to see the shell map. Just causes asserts and hits breakpoints and so on. Good. So let's remove this. Okay, make empty is called here. Good. Let's remove this breakpoint. Let's go to our test map. Let's take these guys. Let's start hacking. And yeah. And then we put a breakpoint here. It's not hitting. That's weird. That is weird. I have to say that is weird. It's probably hitting here. No, it's not hitting there as well, huh? Hold on. Ah, it's a different iterator, isn't it? Or is it not? Hold on. Breakpoints. Why can I not navigate this file anymore? What is this? Object iter. Yeah, okay. So it is leaking this guy apparently. Okay. Okay, let's put a... Oh. I was already wondering why nothing is hitting. Good, so let's go into the simple object iterator. Let's go to the constructor. Okay, let's put a breakpoint in here and make empty. Okay, it is called make empty. First clump is null. Let's put a breakpoint in here. So call stack is here, delete instance. Yeah, through the memory pool object holder. That looks good. Yeah. But it is not, it doesn't have a clump. It doesn't have a clump to begin with, so nothing should be leaking there. I don't understand. Simple object iterator. Make empty. Why first clump? Yeah. Delete instance. Yeah, looks correct to me. This loop looks correct to me. It is being called, but we don't even have one allocated. So let's do the following. Let's put a breakpoint here. Yeah. Let's see if anything allocates a clump. There we go. Okay, so someone is allocating here. Yeah, let's see. What is this? Who's that? Huh? Who's allocating here? Ah, here. Okay. Horde update. There's also hold. Propaganda tower behavior. Do scan. Hold. Ether. Hold. Yeah. Horde updates. There seems to be everything in place here. Let's put a breakpoint and make empty. Let's put a breakpoint in here. How about that? There we go. First clump. Yeah. And then it deletes. Next clump. No. No. Steph detector update as well. I'm not seeing it right now. Something is reportedly leaking, but simple object iterator. I don't see it. I don't see it. What could be the reason? So this thing also complains that someone is iterating here in partition manager. Let's take a look at this guy. Partition manager. Okay, and that one apparently is using object iterator. That one is leaking that. Okay, where? So we probably need to check. We need to check the callers of these functions here. Mm-hmm. 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 So let me put bookmark here, there, there, there. Any others? No, it's just these. Okay, let's see who's calling this guy. Uh-huh. Mm-hmm. Okay, there's plenty of users here. So I guess we need to check if all of these guys call the hold. Oh boy. So far, so good. That's stupid. I'm not seeing a problem here so far. Aha. Here we got one. Special ability update. Mm-hmm. Mm-hmm. Okay, let's take a copy of this guy. Here we are not holding the iterator. There we go. Yeah, that's it. Mm-hmm. Mm-hmm. Here's another one. No, it's being held here. Okay. Okay, it's just this one. But let's also check the other guys. Oof, let me remove some of these old bookmarks. This has the same. Does this give us the same results? No. Oh. Yeah. We also need to Yeah, let's check this one. Iterator. Iter delete instance. Okay, so this one is deleted manually. Okay, fair enough. Let's see this guy here. Okay, there we have a hold. Hold. Okay, so it just seems to be this one. Let's give it a spin and see if that fixes the leak reports. Skirmish. Good. So let's see. Let's remove this. All right. So let's take the guys here. We start hacking. Let's see. Okay, ignore. The performance is outrageous, but that's a separate problem. Maybe it's related to... What is this? What? Ignore. Okay, looks pretty stable now. Yeah. Well, it's growing a little bit. Okay, let's see if we have any reports left. 23. Okay. 23 memory leaks. Leaked a block of size. DMA. What is that? DMA. Vector.h. Doesn't seem to be a big problem. It's really cool that they have these diagnostics here. Yeah. Used less than half its initial allocation. Wasted 9K. I guess 9K means kilobytes. Yeah, that's really cool. The diagnostics here. Yeah. Makes it easier to tweak these guys, right? Good. We have some records now, though. these kinds of loops should be while loops anyway. I located and fixed the memory leaks. We'll open pulls later. Fix the memory leaks in, what was it? In sorting, renderer, and special ability updates. Good. Then I think I will take a break here. Next session we open the pull request for these two fixes, memory leak fixes. And the performance we need to have some looking at, like when these particles run, like the the frame rate is tanking tremendously. That probably needs some looking at. Yeah. But okay, that's a different story. We are not yet fixing performance issues, just stability. The goal is that the game just keeps running forever, basically. Yeah, keep running forever. Good. That was a 3 hours, 22 minutes session. That was good. Maybe I should open a report for, let me see. How big is this guy? 4 bytes. Yeah, let me open a report. Blank issue. Simple object iterator is 16 bytes, but allocated. But allocated in memory pools. This looks like a waste of space. It could simply be a stack. Simply be a stack object. S 16 bytes, but allocated in memory pools. Simply be used as a stack object. Let me add an example. Here. Find another example. Let's take this as an example. This allocates y dot. 16 bytes iterator. Okay, investigate, refactor. Well, is it a performance concern? Not really. Task. I would say we add a new label. Let me add a new label. Optimization, maybe. Actually, we can put it on performance. It's really it's like it won't have any like super practical implication of performance, but it is wasteful, I would say. This could simply be on the stack. I mean, inside it also allocates something, but that is fine. But this object itself, it could be just on the stack, and then we can also get rid of this holder thingy, and it just makes the logic easier, simpler. Yeah, I would say this needs to be refactored in the future, but it's not. We should do it now. Yeah. Yeah. Good. Anyway, I will take a break now. I wish you a great day or night. Until next time. Goodbye.